Hola, buenas tardes a todos. That will be the only thing in Spanish for me today. I'm sorry. And instead of Spanish, you will have a presentation in English with a good French accent. I'm sorry for that. That's the best I can do. If you have any hard times to understand me, please raise hand. I can repeat in German. Ah, shit, it's starting. Okay, so nice to be here with you tonight. Thanks a lot to the organizer, to my friend Nacho as well. I was given 20 minutes to do a technical session about content adaptive encoding. So I will try to make it in 20 minutes.
Under 25, it's okay.
Here we go. So we are going to talk about video encoding, and especially this new technology with content adaptive encoding. First, what it is, what are the benefits, a few general concerns, and then we will see it at work. I would like tonight to compile the content and see how it goes with and without this content adaptive encoding solution. And if we have time, but I doubt, I have a backup plan for question and answers, you will see. So, speedrun, let's go for it. So, content adaptive encoding, the topic is video encoding. As you know, in the beginning and still now, constant bitrate is a very safe approach for doing video encoding. Let's say that you know that for your 1080p resolution, you want to ask the encoder to do 3.5 megabit per second, and you will get 3.5 megabit per second from one end to the other of the VOD or the live event. That's fine, that's safe. That's a bit a shame because for some content, you might not need that much. And that's why you had some other initiative like per title encoding. Netflix was one of the first to do that. For one VOD asset, they would run it with different settings in the encoder and pick up the most relevant, the one that gives the expected quality. For that, the minimum bitrate that is needed. That's where they develop tools like Vima, for example, to have an analysis of the quality with measurements. That's nice, it does work, and then you can guess ahead of time that if the content is an animation for kids or a fast action movie with many dark scenes or sports, you will use this or that setting in your encoder. That's perfectly fine for VOD. For live, it's a bit less funny because you might not know in advance what you will get. And that's where you have a bit more sophisticated approach now with content adaptive encoding. So that's thanks to AI and machine learning. The content will be analyzed on the fly and the encoder will be tuned on the fly to match the desired level of quality with just the quantity of bits that you need. The output is variable bitrate, and that's the story. That's a product that we have at VisualOn since a couple of years. We had a nice award last year. The benefits of content adaptive encoding is that obviously you will reduce the bitrate. Definitely, with a constant bitrate, like as I said, 3.5 megs at 1080p, you will waste bits, and it has an impact on the cost, on the CDN, for example. You can as well try and want to improve the visual quality. That's doable, and you will see it at work. This tool can be easily integrated in any workflow, and I will explain that here. And it is fully standard compliant. So let me make that one a bit bigger. It is interesting. How does that work? The optimizer is here. You see, so it's not an encoder. It just side by side close to the encoder. It will get the content that will go anywhere to the encoder, as usual, but we will grab frames, and we will do analysis of the frames. And that's why we have our kind of secret sauce, magic sauce with AI and machine learning. The idea is to understand that, okay, we are changing. For example, there was a close-up on a football player, and then you zoom out on the stadium. You don't need the same quantity of bits for the two. So you need to understand that, okay, the scene is changing, that's one. And two, you have to guess out the optimal settings for the encoder for this scene. And that's what we do. And for that, you need to have this AI machine learning. A bit of knowledge on encoding is not bad. we had to, and that's why we have this added value at VisualOn since 20 years. So that's the story. And of course, the rest, since we just help the encoder, the output is still absolutely standard. AVC, HEVC, and then you do whatever you want in terms of packaging, etc. So any player can consume the content. You don't need a specific player to play this kind of content. Okay. This tool is available today as a plugin for FFmpeg with software encoding with libx264, 265, and SVT-AV1. We have support for hardware encoding as well with NVIDIA, Intel, Qualcomm, NetInt. And it's available for VOD, live, and as well another interesting tool, which is, if I manage to change the page. You saw my surprise. Okay. So available for VOD, for live, and as well we have a standalone product dedicated to shrink the mezzanine files, the golden copies that you get from the studios that are huge, cost a lot in storage, and take a lot of time if you store them in the cloud to download if you want to do video editing and then re-upload. So we can shrink those files, keep the quality, and provide savings with that. And then the last one here for live, that's always a question, do we add any latency? We do not, because as you see, the content still goes to the transcoder, as usual. It's just that we will grab the frames, do the analysis, and as soon as we can, we'll start to tune the encoder. So no added latency. That was my challenge. 5 minutes for this presentation, then let's see it at work. So what does it take? First, you need to get an evaluation package. We have evaluation package, just ask me. Then we will see what you have in the package. You can check the doc. It's useful, I can tell, even if nobody wants to read docs. Then we will see how to compile, because Optimizer is a plugin for FFmpeg, so we will compile FFmpeg with this plugin. Then we'll transcode with base FFmpeg, Tears of Steel, that's a Tears of Steel 4K AVC, transcoded to 800p. Okay, and with pretty much constant bitrate. So we will do that, then we'll see it at work with Optimizer. And you see Optimizer as a plugin only adds 2 arguments in the command line. One is VO Optimizer, enable or not. And one is the target quality that you want. All the rest is FFmpeg, absolutely standard FFmpeg. That's why it's easy to set up. If you are already using FFmpeg, for example, it's really super easy. And then we'll see, once we have done the transcoding, how we can assess the results. How does that look in terms of bitrate and quality? So let's look at that. When you get a package, here I have a package, evaluation package for VOD, for Windows, for FFmpeg 6.1. We have, of course, a lot of other flavors. And in the package, you get the command line to build FFmpeg with Optimizer plugin. And you have this famous doc that is really not bad to read. It gives all what you need to know for compilation, the parameters, how to run the optimizer, how does work the license control, and then troubleshooting. There are a few settings in FFmpeg that are just inefficient with this kind of tool. Typically, if you force to, what is that? Okay, to a constant bitrate, you will waste the efforts. Here we go. So once that's the documentation, let's see quickly how to compile the optimizer. I will launch my console, and I will, why is it cut over there? Here we go. Users, CD, desktop. Ah. Here we go, sorry, that was a bit long. The compilation is super simple. ./build.sh, enter, boom. And then you can just go and get a coffee or 2 or 3 or 4, depending on your machine. With mine, it's 100 coffees. It's not a server, definitely. So I will just stop the compilation. When this is done, you will see the build out bin folder populated with all the libraries. So that's FFmpeg compiled with Optimizer. Okay. So that being said, in this directory, we said that we will now transcode Tears of Steel with base FFmpeg. I have, of course, populated the directory already with Tears of Steel. If my PC wants to respond, here we go. Tears of Steel 4k.move. It's here. So if you want to launch the compilation, let me do it now. Optimizer VOD MAD. All right, and here you have the command lines. Here you have the command lines. The first one is for FFmpeg. So you just go there, launch. And again, let me say yes. You can go buy coffee because you already don't have enough coffee at home anymore. So you go buy coffee and take other coffees and wait. So we are here, it's just encoding Tears of Steel 4K to 800p with base FFmpeg. Once it is done, let me stop this, stop that. Okay, you get the output file. It's this one here, out FFmpeg. No, that's the YUV. 700 megs. So that's the reference file we want to compare with. If we want to do the same now with Optimizer, let me take, for example, this one, because I like this one with target VMAF 98. So again, as you saw, it's only adding VO Optimizer, the VO VMAF, the rest is just base FFmpeg. We kept, to be fair, the same max rate buff size and the FFmpeg transcoded content. And same, you launch, and you wait. Okay? To prepare this demo today, I did this exercise with different target VMAF. So here we are. Okay. With a target VMAF of 96, we are down to 163 megs. The target VMAF of 97 is here, 200 megs, and the 98 is here with 300 megs. And I will use this one for the comparison. You will see it's interesting because it's more or less 60% less size than the FFmpeg one. So now we want to assess that. What are the results in terms of visual quality? For that, a few tools. So to check the bitrate, that's rather easy. You can use tools like MediaInfo, etc. I personally use ffprop, which is really nice. So let me do it. You do ffprop probe out ffmpeg. You wait a bit, and here you go. You have your overall bitrate and the video bitrate and the audio bitrate. I will use this one as a reference. That's the overall bitrate of the content. And you can do same, of course, with the output, with Optimizer. And again, I want to use the 98 flavor. There we go. So here, where are we? Bitrate, so I think I made a mistake. No, that should be fine. Ah, no, I know why. because I was like, what, 900 kilobits? It's because I just launched the transcoding and I killed the session. So that the file, but nicely reduced. So I have a backup file, so you do the same with ffprop, prepared, out, optimizer, 98. I prefer that. So that's the average bitrate. Okay. Then you can start to populate. That's what we do when we do POCs with customers, partners, etc. We take a set of content and we do this exercise, different VMAF scores, and we populate tables where we compare the bitrate of the reference, in that case FFmpeg. But I have customers who come to me with, okay, this is the output that we get today from our transcoder. We give you the source, do your job, and give me the results with this kind of table. So here you have the savings in bitrate, and then comes the visual quality. As I said, VMAF is a very common tool. We use it. I don't know if you are used to VMAF. It was developed by Netflix. You first have to convert the files to YUV format. That's pretty simple. Here you go. That's even super simple. That's a command line, tiers of steel, 4K.move. You convert to YUV, and you do the same for all the outputs that you want to compare, because the source and the output have all to be with YUV format. So that's easy. I will not show you how to launch the command line. Most interesting is the command line for calculating VMAF. It's here. So it's a bit complex. Once you have a command line that works, given by your R&D, you reuse it, copy-paste, you don't touch. Except maybe for the file names. Okay. And the tricky thing, the resolutions. VMAF will work if and only if you scale up the distorted file to the same resolution than the source. That's why you have FFmpeg, blah, 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 video size 800p. That's my distorted file. That's the FFmpeg one. Then you have video size 4K, blah, 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 blah. That's the original, tiers of steel. And then scale, here we go. We scale the distorted to the same resolution. The rest, that's where I say, I already give it to you, don't touch, don't ask. And just that, you have VMAF template that is not the same if the source is 4K or below 4K. In that case, I use the 4K variant. If you want to launch that, again, path, you basically launch it. You will see it has started. It will process all the frames. And in the end, in my command line, I ask to store the output in a JSON file. So I store that, you open the JSON file, and at the end, you have the average VMAF. Okay? It looks like that. I will take any of them. Not bad. Here you go. That's where you have frame 1, frame 2, frame 3, etc. So for each frame, it will do the calculation. And at the end of the end of the end, you will have. It's really far away at the end. Okay. Voilà. You believe me if I tell you it's at the end? I don't have to go to the end of the file. You will have the average. And that's why you populate your table, again, with the VMAF scores. And I did that, of course, for the FFmpeg and the optimizer with flavor. And we see here we have a better score, like 3 points. Depending on the content, you can start to notice a visual difference in the 6 points, maybe 6, 7 points. But in that case, even for 3, we can see a visual difference. So VMAF is a good way when you have to do this exercise to figure out what are the right settings, etc. In the end, and that's the final QA, look at it with your eyes is always the best. And the best is to do side-by-side comparison. I use 2 tools for that. One is my kids. I have two exact same large tablets, or I have a large screen TV. I run the content at the same time, and I ask my kids, okay, one is better or it's the same? And they tell me, no, it's the same, Dad. What's the problem? Okay, fine. We have the same quality. But this kind of tools, I will show you this one, VCMP. It's interesting. Let me open the console again. Optimizer. Here we go. Here I have stored in the folder the output files with this tool VCMP. It's one tool for Windows. There are some others. There are the same tools for Linux. So VCMP tool.exe out FFmpeg out optimizer. In that case, I will take again the 98. Boom. So the quality is much better on the video project. It's not perfect, but so here this tool. On the left, you have the FFmpeg one. On the right, it's the optimizer one. You can drag the bar left or right to focus on a specific, to see more left or right. You can stop, and that's why you can do freeze frame. Again, the visual quality for end users, like I told with my kids, is really important. That's what your end users will notice. Then for video experts, this kind of tool is good to focus on the detail and check frame by frame how it goes. So here we go. Optimizer, FFmpeg. For me, optimizer is a bit better. It's more obvious at some other places. Let me jump a bit up. Here, FFmpeg. Optimizer, you have more details here. Look at the eyebrows. Okay. So that's basically the idea. Of course, and that will be my last slide. That was a super simple example. I had 20 minutes. I used 21. I'm sorry. Another thing, everything you can do with FFmpeg, you can do with this kind of tool like optimizer. So that's a command line with a filter complex to generate at the same time multiple resolution of the same source. Plus, in that case, different VMAF scores, like 98 for the lower resolution, 96 for the higher. And that was for a customer where we saw that in the end, for his content, 96 was good enough for 1080p, 720p, for example. But for the lower, we asked a bit more quality, so we save a bit less. But for the end user on a small screen or a poor network, the visual quality was, wow, way better. And that's what I had for you today. For the question and answers, the plan is to talk around the beer. And I know that tonight will be tough for me because I am the only French and blah, 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 blah. Do we have time for a question or two?
I think we stick to a beer proposal.
Okay.
Thank you.